Hello, my name's Keith Rucker. So we're just about done with the project on these spindles. We actually have turned and made the new 3/4 inch spindle for the Greenlee shaper. We have straightened using a flame straightening technique the arbor here that was bent on the larger one. So the only thing left to do now to finish these up is to get nuts for both of them. So again, I think I'd showed this in the previous video. Carl, who I'm doing this job for, had sent me a 1.25 inch nut that he had, but it doesn't fit this shaft. So this here, again, I need to recheck it, but I think it's 7 threads per inch Acme threads, and I think this is 8 threads per inch, and also this is a right hand thread and this is a left hand thread. So on some of these old shapers, or even on new shapers, they would have a double spindle. One would be turning clockwise, one would be turning counterclockwise. This nut goes on a totally different spindle. It is the right size as far as diameter, but it's the wrong one. But it gives us a good model to use to copy. So we're going to have to basically make a new one of these nuts from scratch. We'll have to mill the hex, bore it out, and then do internal Acme threads to match this one. And again, I think I mentioned this before. This is, I think it's 7 threads per inch. I like using the inserts on Acme because it's a pretty specific profile. You don't have to, you can grind one, but I have not been able to find an insert for an Acme 7 thread. You can get them for 6, but then they jump to 8. So I'm going to have to grind a tool out of high-speed steel to cut this one. So we'll get to see that process. Now the 3/4 inch spindle is 12 threads per inch, also Acme. This is a standard 3/4 inch nut, so I'm going to use this for my dimensions as far as what size to mill the hex and all that. Of course, this is a standard one, so it's not going to screw on here. But we'll have to make a new one of these. Same thing, mill out the hex, bore it out, and then do the internal threading. And I do have an insert for the internal threading on this one that we can use, so that should go straight forward. So I've got some metal here. This is just a piece of 1.25 inch cold roll. This is a little over 2 inches, 2 1/8 inches, I think. Piece of scrap. I have no idea what steel this is, but it's the right size, and that's what we're going to use to make this nut out of. So I think the process I'll do is we'll start out on the milling machine. We'll mill the hex out first while we have something to grab a hold of. Then we'll put it on the lathe, drill out the middle, and then just cut that off, part it off, and then turn it back around, and then we'll put the threads in. So here we go. All right, we've got this set up over here on the mill to go ahead and cut the hex. I'm going to go ahead and cut the hex on both of these shafts. They're both different sizes, but go ahead and get this done while I'm over here. But we're going to use the same technique I've been using. Y'all have seen this in some of my other videos if you're a regular viewer. I don't have a way to index these. I don't have a dividing head or a super space or anything like that to do this. So I'm using a poor man's technique where I'm using an angle block, a 60-degree angle block, to measure the flats on the hex. This has worked real well for me, and we're going to keep on using this, and maybe one day I'll get a super spacer or dividing head. I actually got a dividing head. I just need to do some more work to it before it needs a few little things done before I can start using it. I just haven't got that done yet. But anyway, we're set up here. This shaft is 2 3/16 in diameter. We want the hex to fit 1 13/16 inch. So I've done the math on this, and actually using the exact measurement of this, and knowing I want to have a little bit of extra room on the for the wrench. I'm going to move the table up 193 inches once or 193 thousandths, excuse me, once I touch off here, and we should be right on where we want to get that wrench on there. So let's get going. All right, we're touched off right there. Zero my Z-axis, and we'll take this up 193 thousandths. Should be about right there. All right, we've got that first flat cut now. So using this technique with the angle plate that I use, getting the first one indexed is the hardest because I really like to measure off the bottom rather than off the top like this, because it's really easy when you just slide this in there and you measure off that bottom angle. So the problem here is that with the first one we got to come in here and index it off the top. It's still not a big deal. We just come in there until that hits flat across that and tighten it up. Now, I did have a suggestion, and I'm going to mention this from one of my viewers that said, why don't you, let's see, get that just right. He said, why don't you flip it to the bottom and use an adjustable parallel and just do the top and then the bottom, and then you can start working off the bottom again on your angles. And that was a great idea. The problem is I don't have an adjustable parallel, I'm embarrassed to say. So I have to put that on my list of tools that I need to get my hands on, because that'll sure make this job easier in the future. So also another thing I'll point out is I've got an angle plate back here that I use to go up against to just stop, and that way I'm always cutting these corners or flats will all match up. If you don't have that back there, when you turn this, it moves in and out, and it just makes it more difficult. So that right there will save me a little bit of time as well. So with that, it's pretty much just keep on doing the same thing over and over. So we'll shoot some video and show you all the process of turning this thing into a hex. So now we're going to repeat the process for this one. Next step here on this project is go ahead and do a little bit of lathe work here. So we've got a couple of things we need to do. First off, on the top, this little extra piece here needs to be turned down. On the original bolt here, you can see where there is a little lip at the top. That's just to protect the threads, I guess, or get it started. I'm really not exactly sure, but that's the model we're going to follow. And then on the bottom, there's another circular piece. So basically what we're going to do here is we're going to turn this top piece off to give that little small piece on the tip, and then we'll use a parting tool, come in here and part it off, and we'll have it ready to chuck back up to bore out and bore for the threading. So let's get this done. Alright, we're just about to the point where we're going to have to bore the nut out, so to the diameter, and of course it needs to be at the root diameter of the thread that we're going to be doing, which is an Acme thread. And to make matters a little complicated, you know, neither one of these are standard size Acme threads. They're you know, 3/4 12 and 1 1/4 7. It's not something you can just look up in the book and see what size hole to drill. So we had to do a little bit of mathematics and looking things up to figure out how to do this. So I got my copy of Machinery's Handbook here, which is a good reference that every machinist needs to have a copy of. And I went to the section on Acme threads here, and it has all kinds of really good information. So I was able to look up the threads per inch, and there's a chart here, and I got 7 and 12 on there. And it tells me the D diameter here, which is the depth of thread. And I can look that up for, you know, both of these thread pitches. And I took that measurement and doubled it, because obviously we got to take that much off of each side for a diameter. And then I read down here in the note in the bottom, and it says, let's see, a clearance of at least a 10 thousandths of an inch is added for depth H on threads of 10 per inch and coarser, and 5 thousandths inch for finer pitches. So again, doing all my math, I was able to take the thread or the depth of the thread, double it, and then add on to that diameter. It'd be 20 thousandths and 10 thousandths, which again, we need to add 10 and 5 for each side. And from that, I'm able to calculate my diameters that I want to actually bore to get enough clearance in there for this to work. So hopefully we got all that figured out, and we're going to head over here to the lathe now and get that going. We just drilled that out to 5/8 and just making a rough measurement with my calipers. You know, I'm a little bit over. I'm at about 630 thousandths right now. We need to go to 676. So I've got a little 1/2 inch boring bar in here. I'm going to just start making a light cut, true it up. We'll get a good measurement and get this bored out right where we need it. We went over about 1,000th, but I think we're going to be fine on that. This is just give us some clearance. So we're going to call this good and go ahead and get ready to start threading this. All right, I've got my 12 pitch Acme internal threading tool in there on a lathe flat set up. Got my pitch set to 12 threads per inch. We're doing internal threading. So again, the compound is set at 14 degrees, coming backwards from normal, because we always want to cut on this leading edge up here. So I think we're ready to go. We'll scratch off in here. All right, we'll set our 0 right there. And I'll start by doing a scratch test. And that's nice. All right. Again, I don't have a insert for a number 7 or a 7 pitch Acme thread, so I'm having to grind one by hand. So in my hand here, hopefully you can see this, is a Acme thread gauge or threading cutter gauge. And what I did was I took a piece of high-speed steel and I cut a leading edge on it so that it fits down inside this groove. And that fits real good. This was all done freehand, just on a grinder. I didn't shoot any video of it. It's just hard to do that over there. Don't have good light over there. But still, I did it all freehand on just a grinder. And then the next thing you have to do is get your tip the right width, and I'm using the number 7 here, and I go down in here and get it just right. So I've got a piece of high-speed steel now ready, and we're going to put this in a bar, and hopefully we'll get ready to start cutting these threads. Alright, hopefully you can see this. I've got this mounted now in a boring bar, just for high-speed steel. And that should be ready to go on the lathe. This set up for doing our 7 thread per inch Acme threads. My tool set up in here, already touched off. We got the machine over here set to cut 7 threads per inch. So we're ready to go. Let's get this one done and knocked out. I think we're good to go now. Yeah, we're good to go. All right, that wraps up another project. These arbors, our spindles, are 100% complete now and ready to go back to Carl. We got the nuts made for both of them. The 3/4 inch 12 Acme thread fits real good. Here's the 1 1/4" 7 Acme thread. I think I said 9 earlier, but it's actually 7. That's why you need to measure this stuff and not go off of memory. So anyway, we'll get these boxed up to Carl and get those headed to him. Carl, I hope you like them. I hope they work good for you. Be sure and shoot some pictures or whatever once you get these on your machine and try them out, and give me some feedback as to how they work, because I'm pretty happy with them. I think you're going to be happy with them as well. So once again, I want to thank all my subscribers out there who watch this stuff every week. You know, I really appreciate it. Without you, I don't know that I'd continue doing this. But last time I looked, I think we were up around 6,700 subscribers now. and that's growing every single day. Should be hitting 7,000 here pretty soon, and man, that 10,000 goal for me is right around the corner. Again, I still can't believe there's that many people out there that enjoy this stuff like I do, but you know, I'm glad there are. I love it as well. So I got a couple other videos that I'll be getting posted online hopefully over the next week or so. I got a bunch of little small projects that I knocked out in the evening this past week, several for the museum and what have you. And I know this coming week I'm traveling again, but should be back around next weekend, and hopefully be back out in the shop again. So again, thank you for watching, and we'll catch you next time.